11.5 Lines and Planes in Space. In this video, I will be discussing both lines and planes. How do you find the equation of a line in the plane? So, line in the plane, an equation is y equal ax plus b. We use slope, which is here a, to determine the equation. How about in space? In space, we consider 3D. X, Y, Z. How do you find the equation of a line in the space? It is more convenient to use vectors to determine the equation of a line. In this 3D space, consider the line L go through the point P, x1, y1, z1, and I say this L, and parallel to the vector V. So V vector A, B, C. Here V is a direction vector and components x, y, z component a, b, c. A, b, c are direction numbers. Since line L parallel to V, we know is line L parallel to V, the vector on the line has to be a scalar multiple of the direction vector. That means we can find a vector. I use any point on the line which is say called Q. Q is X, Y, Z. Any point. Then we can write PQ vector equal scalar T time V. Y, T is a scalar here. Y, line L and V are parallel. Therefore, any vector on the line is parallel to vector V. Therefore, we can write as a scalar multiple. So, T is a scalar. Then, how do we find the PQ? You know already, PQ is X minus X1, Y minus Y1, Z minus Z1. If you don't understand this, let me explain. This is the P and this is Q. So, position vectors like this. So, this one is P is X1, Y1, Z1. So, Q is X, Y, Z. Therefore, position vectors should be this one, OP, X1, Y1, Z1 and OQ. This one, X, Y, Z. So we can find the PQ vector equal PO vector plus OQ vector. PO vector is negative XYZ, X1, Y1, Z1 plus OQ vector is XYZ. So then we can get the PQ vector. Right. Then we know V vector. Therefore, let me plug this X minus X1 and Y minus Y1 and Z minus Z1 equal t times v is a, b, c. You know two equal vectors. If vectors are equal, components are also equal. By equating corresponding components, we can obtain x minus x1 equal 80, y minus y1 equal bt, z minus z1 equal ct. So from these three equations, we can have x equal x1 plus 80, y equal y1 plus bt, z equal z1 plus ct. This one is we call parametric equations of a line in space. If A, B, and C are all non-zero, then we can have, if A and B are all non-zero, we can have x minus x1 divided by A equal t, y minus y1 divided by b equal t, z minus z1 divided by z equal t. From the above this equation, we can write x minus x1 over a equal y minus y1 over b. This equal z minus z1 over z. This is called symmetric equations. Symmetric equations of the line. Right. How about if a direction number is 0? Yes, let me write here. If a direction number is 0, then the line, what do you think, lies in a plane. Suppose this. Suppose a equals 0. Then if a equals 0, what do you get? X equal x1, right? Because plus 80, that part is 0. Then what is the x equal x1? This is a plane, right? This is a plane parallel to YZ plane, right? Yes. So again, if a direction number is 0, then the line lies in a plane. Lines are parallel if their direction vector are parallel. Yes, it is clear. lines are parallel if their direction vectors are parallel. So CB. You see that. Let me explain this example. Find parametric and symmetric equation. Find parametric and symmetric equations of the line that passes through the point 2, 1, negative 3 and is parallel to V 1 minus 2, 4. Right. So, find the parametric and symmetric equation of the line that passes through the point. Right. So, you know this is a 3D. So, and this passes through the point. Yes, I said this. 2, 1, negative 3 and parallel to V. V is 1, negative 2, 4. To find the equation, we need the direction vector and a point on the line. Yes, we know those, right? So comparing the theory I explained above, we can say here direction vector is V, so A is 1, B is negative 2, C is 4. And point P, x1, y1, z1. So we can write x1 equal 2, y1 equal 1, z1 equal negative 3. Now using this equation, x equal x1 plus at, y equal y1 plus bt, z equal z1 plus ct. So we can plug the numbers. X equal x1 is 2 plus a equal 1 t. Similarly, y equal y1 negative 2t, z equal z1 negative 3 plus 4t. So this is the symmetric equation, right? So then, this is the parametric equation. So then how do we write the symmetric? Then symmetric equation is x minus 2 equal y minus 1 over negative 2 equal z plus 3 over 4. So this is the symmetric equations. So next, let me explain this example. Suppose there are 2 points, negative 2, 1, 0 and 1, 3, 5 2 points. Then find the equation of the line. Passes through the points. How do we find the line passes through these 2 points? So if I draw the line, this is a 3D. So I say this is P, -2, 1, 0. And this is Q, 1, 3, 5. What do we need? We need a vector parallel to this, which is called a direction vector. We need ABC and point on the line. Yes, there are 2 points, so I use this one. We can use either. I use that one. Yes, so therefore we have x1, y1, z1, right? So x1, y1, z1, I can write it is -2, 1, 0. Now we need find the v. How do we find the vector v? Yes, we know the vector pq. We can find the vector pq. Yes. So let me find the vector pq. How do we find the vector pq? Pq is, 1 minus -2, 3 minus 1, 5 minus 0, right? So this is 3, 2, 5. Then we can use this as a v because we need a vector parallel to the line. So this is parallel to line, right? So this PQ vector. So right, then this is v. Then we know this is the A, this is B, this is C. Therefore, we can write the equation x equal x1, it is -2 plus 3t, and y equal 1 plus 2t, z equal 0 plus 5t. So this is the parametric equation. So then how do we find the symmetric equation? If we have parametric equation, we can find the symmetric equation. This equal y minus 1 divided by 2 equals z over 5. This is the symmetric equation. So how do we find the point on the line? You can find any point on the line, plug in the values for t. So let me try t equals 0. If you plug the t equals 0, you will get x equal -2, y equal 1, z equal 0. Right? And plug the t equal 1. That is the point on the line, right? You know that is the p point P. Then t equal 1. So t equal 1, you will get x equal 1, y equal 3, z equal 5. So that is the point Q. Next example, suppose the equation of a line is x minus 1 over 2 equal y plus 2 over 4 equals z minus 4 over minus 4. So then what is the direction vector of the line? Yes. How do we find the direction vector? Now go back to the theory. We know the line equation x minus x1 over a equal y minus y1 over b equals z minus z1 over c. So here direction vector is a, b, c. The point on on the line is x1, y1, z1. So use this. Now we know they are asking direction vector. So direction vector here A is what? Here this is the A, this is B, this is C. Therefore, we can write direction vector of this line is 2, 4, negative 4. That means, so this line, suppose this is line L. So L is this, and we know this is parallel to vector V. Then how do we find a point on this line? Yes, we know x1. Here this is x1, and here you can find the x2. So what is the x2? Let me write down here. x1 is 1, x2 is negative 2, and similarly, y1, right? y1 is negative 2, and z1 is negative, it is positive 4. Why? Because this is negative, so therefore this is z1, right? 1 minus 2, negative 2, and 4 is a point on the line. Can we convert to the parametric equation? Why not? Yes. So we can write a parametric equation. It is x equal, let me use white. So x equal 1 plus 2t, y equal negative 2 plus 4t, and z equal 4 minus 4t. So this is the actually parametric equation.